Okay. This is the chapter 3, quiz C, last one. Review covering sections 3.7 to 3.9. And I need your questions. I'm not just going to go over them one by one. So tell me what you'd like to discuss with problem number and if you've got one in the book that you'd like to look at. So I take it you're just now starting your review.
Yeah.
Okay, whoever's watching, hang in there. We're gonna wait for people to catch up.
Can we do 22 on page 162?
What problem number is it?
Number 2.
Number 2?
Yep.
And on page, what?
162.
Number 20,
2.
22. Okay, the instructions for all of these on page 162, number 22, the instructions for this set of stuff says, find the lines that are tangent and normal to the curve at a given point. 22 is not even a function, I doubt. It's just it's an equation. It's got x's and y's in it, which means we're going to have to apply implicit differentiation. So would you read it to me, please? Hang on a minute, let me get set to go. Go ahead.
X squared minus the square root of 3 times x and y plus 2y squared equals 5. And the point is square root of 3 and 2.
Square root at x equals root 3? Is that all they give you?
No, root 3.
root 3, 2.
Oh, root 3, 2.
Yeah.
Okay, so to write the equation of a line, either one, we're gonna need a point and a slope. They gave us a point, that's good. What we need is a slope, which means we need a derivative. Yeah? Okay, since this has got x's and y's and all mixed together here, I'm gonna use implicit, so it's gonna be 2x, because that's just an x term. This derivative is just 2x. This I'm going to treat as negative root 3x times y. So when I do the first times the derivative of the second, it looks like this. And then plus the second times the derivative of the first. Now remember, there's a couple of hiccups you could have here. If you decide to just do this and you want to call it root 3x times y, then you're going to have to put the two terms we get from doing the product rule, you have to put that in parentheses so that you can distribute the negative later. I'm not doing that. I'm deriving it as though the coefficient on x is negative root 3 and it'll carry through and I won't have to distribute it. Is that okay? Okay. So I took the first, which is negative root 3x times the derivative of y dy dx plus the second times the derivative of the first. And the second is y and the derivative of the first is negative root 3. This is the second times the derivative of the first.
Wouldn't the derivative of the first be 0?
No. The first is negative root 3x.
X, okay. I didn't see X.
That's okay. Are you good? Are you keeping track? Anybody question me so far? Got a y term here. That's going to be plus 4y dy dx equals 0. Yeah?
Yeah.
Following all that? Get your dy dx terms together and factor it out. I'm going to factor out dy dx, and I'm going to put the 4y in front because I like to subtract things rather than put negatives on the front. And the other guys that aren't that way, I'm going to take that over and put him in front so he can be positive, and then minus 2x. Follow that move? Okay, and then we divide. And then plug in to get the slope for the tangent. We plug in root 3 and 2 into this. To get the slope for the normal, we plug root 3 and 2 into this, and then turn it over and change sign before we write it. So we got to plug that in. I'm going to say at P, and And that's going to be root 3 times 2 minus 2 root 3. Oh, that's nice. Did I do that right? 2 root 3 minus 2 root 3. Well, that's going to be 0. That's going to be 4 times y is 8. And root 3 times x is minus 3. Doesn't matter. 0. So now what?
You can figure out what crosses the y-axis.
Crosses the y-axis at 2.
So it's just y equals 2.
Y equals 2 is tangent there. So the tangent line, this one turned out kind of, I guess, kind of nice, but also a little weird, so it's kind of hard to understand. The tangent line is going to be, if you really want to go follow through the whole thing, is going to be y minus 2 equals 0 times x minus root 3. And that's y equals 2. Right? How do you find the reciprocal and change the sign of 0? The answer is you don't. It's undefined. So to do the normal line, if I'm clear off the page yet, and I'll do it over here. The normal line, you've got to understand the normal line has an undefined slope, which means it's vertical and goes through that point. That's x equals root 3. Follow that? Okay. Probably won't be that strange like that on the quiz, but it's this process right here that you got to know for the quiz. I'll give you something like this. You got to find a slope, plug in the point that they give you, and write a line, I think. Let me read it exactly. It says, yep, here's what it says. Find an equation of a line that is, and I'm not going to tell you whether it's tangent or normal, but it'll just be one or the other. You got to be able to do them both. Find an equation of a line that is either tangent or normal to the graph of, and it gives you a function like this to derive, well, that's not even a function, an equation to derive, and they give you the full point to evaluate it at. So you don't have to go find your y or anything. They give you a point, you got to go find the slope. And either use it directly or turn it over and change its sign, depending on the instructions that you're asked to do. Okay? And just so you know, the equation of the line that it gives you for options, you get 5 choices to choose the line. The equations of the lines, if they are fractional, are fractions, not decimals. I don't suppose that matters to you, but I'm just telling you. Other questions?
Number 21 on page 170.
Okay, that's in section 3.8. Number 21 on page 170. In case you didn't hear that on the video. It says, find the derivative of y with respect to the appropriate variable. Well, the appropriate variable is x because it's the one it's written in. Find the derivative of y. That's all we're doing. But it's plenty there. We've got the inverse cotangent and the inverse tangent in the same expression. We've got 1 over x and x. Okay, will you read this one to me?
All right, inverse tangent
Inverse tangent?
of root x squared minus 1.
That's not the one I saw. Which one? 21?
Yeah, 21.
Ah, 21. Okay. Sorry, we don't have a cotangent and inverse tangent. We've got an end of
Root x squared minus 1 plus inverse cosecant x.
inverse. Like that?
Yeah.
And x has to be greater than 1.
Okay. That'll be a nice thing because if x has to be greater than 1, if we have to use absolute values, we can ignore it with this domain restriction, right? Okay. So dy dx. Better remember the derivative of inverse tangent?
It's
1 over 1 plus u squared.
1 over 1 plus u squared, which in our case is just x squared minus 1. Because when you square that, you get just what's underneath. Times the derivative of that, but I'm just saying, this is the first part. Does that make any sense to you? I realize the one's that out, but don't get distracted. We'll do that next time. Times the derivative of this, which is the derivative of a square root. We all know the derivative of the square root of x is 1 over 2 root x, times the derivative of the inside. Did I lose anybody there?
Oh, yeah, can you go over that one more time? Sorry?
If you have root x or root u, I don't care what it is, root something, its derivative is 1 over 2 root that something.
Yeah.
That's what I did there. So the derivative of this part of it is 1. That's a 1 right there, right for right now. It's 1 over 2 root that.
Yep.
Times the derivative of the inside of that.
Yeah. Okay.
Everybody clear? You sure? Okay. And I know that will simplify too. We'll do it next step. Just getting the derivative here. Cosecant is a cofunction. It's the cofunction of secant, which means that when I add this derivative, it's actually going to be subtracting the derivative as though that were a secant. Remember, it's just the opposite.
Yeah.
And what is that?
1 over x.
Absolute value of x, which again, I will simplify in a minute based on this, but it's the absolute value of x, square root of,
X squared minus, or 1 minus x squared.
is it?
X squared minus 1.
X squared minus 1.
It is
I
x
think the
squared
1 minus x squared goes with sign.
Is that the only one that 1 minus x squared goes with? I thought x squared, I thought it was 1 minus x squared. I'm sorry.
I think sine is 1 minus x squared.
Yeah, it is.
I think
Yeah,
secant
sine
is x squared
I
minus
thought they
1.
were both, that's my bad.
Okay? Are we good?
Yeah.
Everybody in agreement up to this point? There was no chain rule required on this. So now I'm going to simplify. This simplifies to 1 over x squared because the 1's that out. This simplifies to x over the square root of x squared minus 1 because the 2's cancel out. And this simplifies to 1 over x root x squared minus 1 because of the domain restriction. I would accept this. I think that the author, because it's each of the denominator pieces is pretty close. I mean, there's pieces of a common denominator. We could find a common denominator and,
Can't you just?
oh yeah, wait.
multiply the first one by
I would not accept this. You're right. That's a times. I'm thinking that's plus sign, it's not a times. So it should be x over x squared root x squared minus 1 over x root x squared minus 1. And this is a very small step to get a common denominator here. All you got to do is multiply the top and bottom of this by
Wait,
x.
Wait,
no,
you
you
cancel
could
the
just-
x out.
Yeah.
What?
On the
In
other
the
side.
first term? X over x squared.
Here?
No.
Yeah.
Oh, yeah, better, even better. Gosh, good thing I'm not taking this quiz. So yeah, in this one right here, you're right. Once I combine these together, this cancels with this. And then I have minus 1 over x square roots of x squared minus 1. This was, when I canceled this, there was a 1 left. And so, big fat goose egg. Sorry. Yeah, I'm going to screw that up. I might not have if I was a ways away from it like you guys are. When I have short arms and right next to the board. Awful. It's my only excuse. It's not really an excuse, it's an explanation. Anyway. So yes, that turns out to be 0. Anything else? I can mess up. Which one did that refer to? So I can give you any hints I can off of that.
That was number 3.
Yeah,
Number 3? Yeah, number 3 is easy. You'll be fine. A lot easier than that. However, number 3 does require you to have memorized the inverse big function derivatives. I'm not going to tell you which one it is, but it does involve that, so make sure you got them all down in your head. There's really only 3 to memorize, right?
Yep, and you just slap a negative on.
Slap a negative. Okay, anything else you would like to discuss?
Number 4. Yeah.
Well, give me a problem that you've looked at, or you want to look at.
Well, it's
Well,
just
it's
a
not
difference on
example.
Yeah,
Yeah, number 4 just
Wow.
has an example.
it has 4
Yeah,
5 different options.
yeah.
And you,
All right, number 4 is on the review. And by the way, anybody viewing this, I don't know if this helps. You can take a picture of that or whatever. I hope you can see that. But this is the review that we gave that we're looking for. Just in case somebody comes along and wants to subscribe, they need to know what we're doing. Okay. All right. So number 4 on here, I wrote it because I couldn't find anything like it in the book. So let's discuss this. It says, If f prime of x is 4x to the 3/5, f prime of x is 4x to the 3/5. And because of the glare, I gotta find a better pen. So hang on, it's not gonna be dark enough to see. This one's any better. Okay. And this is what it says, which cannot be true. Which of the 5 is no good? So these are our choices. F of x is equal to 5/2 x to the 8/5 plus 3. That's one option. That's A. B looks like this. I'm going to put it all down here for the people that are viewing. That's all. That's the only reason I'm doing this. Besides that, I want to be able to reference these and talk about them. So just give me a minute. Equals 12 over 5x to the 2/5. B or C is f of x equals 5/2 x 5th root of x cubed minus 4 d. The third derivative is 24 over 25 x to the 7/5. And I guess you can still see this. E would be f double prime, no, triple prime of x is equal to negative 24 over 25 x 5th roots of x squared. Means I like problems like this, even though they're multiple choice. You have to consider every single option. That's a nice problem because it makes you think really hard. So if the first derivative is this, and this is the only one we know for sure is true, if that's the first derivative, 4x to the 3/5, then you may ask, well, could this be the original function? Your best bet, at least until we start discovering or start doing things called integrals, that won't be till the middle of next trimester. What you could do though is take this and derive it and see if you get that. Right? That's how you can investigate if this is true or not. Yeah. Okay. So if we take the derivative of this, you get 8/5 times 5/2, which is 4, right? It's 40 over 10, which is 4x to the 3/5. And the derivative of 3 is 0. So this one's true. So this is not the one we choose. See what we're doing? To figure out if the second derivative is this, we have to derive that. So now we're deriving the original because we have the first derivative. We want to derive it to get the second derivative. So if I derive that, boy, this board is getting really full. If I derive this to see if it's this, I'm deriving this, I would get 12/5 x to the negative 2/5. Do you agree? And it doesn't look like that, but it would if we just tucked that downstairs where it belongs, in my opinion. 12 over 5x to the positive 2/5 is what you get when you make your exponents positive, and sure enough, that's a true one. You see what we're doing?
Yep.
Okay. We want to know if this could also be the first one. You go, well, no, this one was. Could this be it? Well, it's a different way of writing it. Could this be the first one? Well, again, we could derive this, or we could take the derivative that we got and see if it is really this. No, I got to derive this one. Sorry,
Just
better derive this
simplify
one.
that one, and it's the same.
It's 5/2 x to the, this is the same thing. This right here is 5/2 x to the 3/5.
Don't forget the X in front.
What? Oh yeah, the x right there. So right now, this is 5/2 x times x to the 3/5, right? And that's the same thing. If you remember, you've got to add these. This has to be 5/5 here because it's a 1.
Right.
So this is really 5/2 x to the 8/5, whose derivative is the same as this one because it doesn't have a constant, but it doesn't need one. Because the derivative of 0 is also 0. So I guess what I'm saying is I already looked at this, but I had to rewrite this thing here to see in order to do the derivative, and I discovered it was the same as this, it was out the +3. So this thing's derivative is this, and so this one's true. The third derivative, since we decided that the second derivative we dealt with here in B, when decided that was true, we need to take that derivative now and derive that to get the third derivative, because we know this is the second one.
Yep.
Yeah? Yeah, okay. It's sitting right there, or right there. They're both the same. Okay, so if I go take a look at this one, I want to derive this to compare it to this. So this is how I'm studying this one. I'm going to take this one right here, which is, I'm going to write it in this form, 12/5 x to the negative 2/5 again. Put it back up there so I can use the power rule. And the derivative of that is what?
It's negative. So
Negative 24/25
Yeah.
x to the negative 7/5.
once you saw the negative on the front, can you just like see that there's no negative on the option B?
Okay, so this one right here is really, if you make it proper, in my opinion anyway, it would be negative 24 over 25 x to the positive 7/5. That is not what this says. That's what this says. This is x, if you think about this down here, this is x to the 2/5 times x to the 5/5. That's x to the 7/5. That belongs, this is x to the 7/5. And I've got negative 24 over 25 here in E, but I don't have that in D. So this is the false one. And this one's true. And this was only false by a negative sign, but it's false. So do you understand how to investigate this?
Oh, yeah.
Number 4 on your quiz is very much like it. Different function, different things given here, but that's the way you're going to look at it. Try to figure out which one's bad. It says on number 4, which cannot be true if f prime of x equals. It gives you a function very similar to the one I gave you.
So number
Anything else?
5.
What?
Number 5, it says just no calculator conversions, and there's no number for it, so we're just.
Right. Here's what it says. In number 5, it says which expression is equivalent to. And it gives you one of those 3 things on the left, and you've got to find the one that's on the right.
Okay.
So if you know your calculator conversions, the stuff on the right, what it belongs to on the left, you will ace that one. And if you don't, you'll have to guess at it.
Cool.
Calculator conversions, y'all know where to find those?
Page 169.
I know I've asked you to commit a lot of things to memory, but these things have got to be in your head if we're going to proceed and with any sort of efficiency. So yeah, the calculator conversions are on page 169, and secant and cosecant are just their reciprocal buddies, but the reciprocal happens in what you're inversing. But the cotangent's a little different. We have to do that one with pi minus the inverse tangent of x, which is down below. No, it isn't. It's kind of this. Anyway, it's a little bit different. Know those 3. You will have to identify one of them in number 5. Anything else?
So on number 6, the ones that you wrote down on the page, you just want you to find the derivative of those, and that's it.
Yep, you just find the derivative of y.
Why not?
Let's do that.
You want to do it?
Yeah, sure.
Number 6? So what I've got here for you actually is just 2 examples. You want to work them both?
Yeah.
All right. I hope you've tried it yourself so you see if your work and my work match. Watching me do it, you guys, is not preparation for the quiz. Doing it by yourself without aid of any kind, that's when you're prepared, if you can do it right. Not watching me. So I hope you're practicing this. And for me doing these, now you got nothing to practice. So maybe I'll do the first one and you guys do the second one. And we'll see what happens. Y equals 3x squared plus x minus 2 tangent x. We'll work on that one. That's number 6 at the bottom, very first one. And all it says is find dy dx. What do you have to recognize here to do it correctly?
Product rule.
Product rule. That's the thing you got to notice. People mess up the product rule all the time, and I don't know why. I don't know why you don't see it as a product. You've been doing this in algebra forever. So we take the first. times the derivative of the second.
Squared x squared x.
Thank goodness you know that one. Plus the second times the derivative of the first,
6x
Plus 1.
and they will probably have this on the front of the tangent. It's just customary. So the only difference would be instead of this term right here, we would have this. Because you're going to be choosing them out of a list. This is the customary way of writing this. So it'll look like that. Or they might even have this out front and then plus this, but you just got to find the terms. Does that make sense to you?
So that's it?
Yeah, that's it. That's it.
Straight up. Straight up.
If you recognize it as the product rule, it's not very hard. But a lot of people don't. So I'm warning you, that's the product rule. Now, you do the second one. Let's see what you get. See if I can do it. Don't look up here unless you need to, unless you're ready to check. And again, I may not be correct because I'm not doing very well today. Is that correct? Yeah?
Yes.
Okay. So if you recognize the product rule, it's not very hard. If you don't, you'll mess it up. And the author anticipates very carefully, very, very concisely the mistakes that I guess students he's had made with this one. And they are options as well. Cool. So, yeah. Anything else?
So like number 7, number 41.
What page are we looking at?
On 178.
Hang on a minute. Let me get there. I have to go slow because I got so many pages in here. 178, number
41.
41, okay.
Just when it says state the domain, how do you know like what the domain is?
You have to prevent you have to prevent any logging of negatives in the original and in the derivative. You want to do 41?
Yeah, let's do 41 and just kind of explain.
Okay, 41 is log base 2 of 3x plus 1. Or are we just finding the derivative?
Yeah, it's just the derivative and state the domain.
How do you do it when it's not a natural log? It's 1 over what you're logging, right? Whether it's natural log or not, it's 1 over what you're logging, right? But when it's not natural log, you also have to natural log
The base.
A, which is 2. The base, right?
And times
Times the derivative of the other stuff, which is just 3, right? So we end up with 3 over 3x plus 1, natural log of 2.
X is greater than -1/3.
It also can't be 1/3, a negative 1/3, right? You have to prevent division by 0, but you also, remember, you can only log positive things. So what you really want to do, I mean, this isn't a problem. Logging, in the derivative, all we have is the log of 2. That's no problem. That's gonna be that. And this we only have to prevent division by 0. But we will prevent division by 0 with this if we prevent this from being a negative or 0, right? This is the problem. So what we're trying to say is, over here, we're saying we can only log things that are positive. So when is this thing we're logging positive? That's what the question is. We get 3x greater than negative 1. X must be greater than negative 1/3. That's your domain. Does that make sense to you?
Yeah.
You got to make sure that you are in the original, because this hasn't got a problem except for division by 0. But if we ensure this is strictly positive, we dodge that bullet here. So we want to know, when is that positive? So you write down, when is that positive? Solve it. When x is greater than negative 1/3. That's the domain we should have. And that satisfies both the conditions for this, for logging positives, and for avoiding division by 0. Is that the one I gave you pertaining to number 7?
Yeah.
One of the ones.
Yes?
Yeah.
Okay. I will tell you on number 7, I'm not going to tell you which one it is, but it will be one of those 4 transcendental functions, either e to the x, a to the x, log base a of x, or natural log of x. You better know them all. I hope you learned them as you did this exercise. And if you haven't done this exercise, well, then you're behind and it's your fault. So the only one we didn't discuss is number 1. Does anybody want to?
What was that?
Discuss number 1.
Sure. Why not? Wait, did I already go over one? No, I didn't.
No, let's do it.
Let's do number 1. Cover all bases, shall
What have you got to do? What's the quiz say?
Find you
162?
Yeah, it's
Yeah.
good.
It's
You want to do
number
simple?
2, find you x.
Yeah. Using implicit?
Yeah. So it's like 1, 2, 6, 7, 8. Yeah.
On this page, 1, 2, 6, 7, 8. Okay. I want to show you number 8 is very similar to what you have to do on the quiz, but I want to show you the way it's written and the way people mess this up. It has nothing to do with your ability to take derivatives. It has everything to do with your ability to slow down your eyeballs and see what is presented to you, because you'll wash right over it if you're reading too fast, and you'll do the part that your eyes tell you that you see, and then you won't do the part that you don't. It has nothing to do with the math. It has to do with the way it's written on the quiz. So 8 is similar. It's not exactly like it, but 8 is pretty similar, and it's written like this. If I were to write number 8, the way the quiz writes it, they write this. Find dy dx if, and then this is the way it would be written if number 8 were the question on your quiz here. Here, like this. And people walk right over this because it's right after the word if. They see that y, they do not see that x. For some reason, it's amazing to me how often people miss this. So I'm warning you. They say, find dy dx if, and you're so used to seeing y equals this, and you go, oh, that's got x's and y's. I have to use implicit differentiation over here. And they write this, dy dx. Well, over here, they see the y, so they write dy dx equals, and then they derive this implicitly. This requires the product rule. They just don't see the x. I'm not sure if they don't see it or they just ignore it or what. Or they're saying that's going to be the derivative of x, which is 1 times the derivative of y. I don't know how they're seeing it. However they do, they're doing it wrong. This is not what you write here. You write the first times the derivative of the second plus the second times the derivative of the first. That's the left side. You see it? Do you really see it? Okay, because people don't see it other places. So if I do this one, that's going to be 1 plus cosine y dy dx. And I assume you can proceed from there, but I will continue just to complete this review for the video will be x minus cosine y dy dx, in bringing the dy dx over and factoring it and the dy dx out equals 1 minus y. You agree with that? Okay, so dy dx is equal to 1 minus y over x minus cosine y. Yes.
Okay, so when I was doing this, I just like, when you subtracted the cosine over, I
Yep.
subtracted the x
Yep.
over.
Mhm.
Does that matter? 'Cause then
It
the
does
sign
not
is
matter.
like-
If you did it that way, then this is what you would have for your answer. You would have y minus 1 over cosine y minus x, correct?
Yep.
Are they the same? They are the same. And I'll explain why, but the reason why it's important that you understand that they are the same and how to get one from the other is because if you get this, and this is the right answer to choose, you may not see it. You know what I mean? Because you're doing multiple choice. You got to know that these are the same. And this is what you would get if you took this over there and factored out the dy dx and this over here and then divided. Here's how I know they're the same and the way I was able to write that down so quickly. Because if you'll recall, we learned this in algebra. If you have x minus, well, let's say 4 minus x. If you have 4 minus x as a factor, say, for example, and on top you've got x minus 4, and you go, well, couldn't I cancel those? And the answer is yes. If you account for it with a negative sign, those are the same, because 4 minus x with a negative factored out is negative 4 plus x, and that's x minus 4. But there's an additional negative there. See what I'm saying? So these have both been turned around. If I reverse that subtraction, I get y minus 1, but I need to account for it with a negative. Right? If I reverse this subtraction, I get x minus cosine y, or cosine y minus x. Sorry, this one. But I must account for it with a negative. But a negative over a negative is positive, and they're equivalent. That's one explanation.
Okay.
So if you have this, and this is the correct choice, you need to know that the reversal of both of these is okay because you get a negative in both cases, which cancels. You see what I'm saying? Okay. Another thing you could do is, if you get this and you don't see any of your answers there, start over and go the other direction. Then it will produce this one. That's another way around it. But they are equivalent because you can reverse subtraction by factoring out a negative. Okay? But I am really, really shocked when I look at people's work on this one. I'm going to remind you again, when I give them this one, they write dy dx here, which is wrong. So watch for it. Be careful. Anything else you want to discuss about the quiz? Okay. All right. There's the quiz review. Good luck.